thank you so much for inviting me here. I'm not sure if you realize how risky it was. I am going to do a bit of a heretic talk, actually, and talk about how smart is smart when you put it in an advanced industry like construction. So, a few years ago, some of the projects that we have recently completed, they are all amazingly smart, obviously. We have also, what Alan didn't say actually earlier is that the Carbon Bus project is a UCL, a joint UCL, an industry initiative, and UCL has been very actively supporting us in this work. So, data. One of the things as a person being responsible for the sustainability of a global, of the projects of a global practice, I thought the first thing that you can probably do is actually understand how much energy your buildings are going to be consuming. And I thought this was going to be a very simple matter. In fact, not so. It took me quite a number of years to get to the point that you see this list of projects with a design starting point for energy consumption, and you can see some of them have now the operational data against that. I think it's taken us something like 6 years to get to this point. So sometimes simple questions can be a lot more complicated to answer. If you see the left-hand side contains some of the design figures, and see they're all C, A, B, architecturally and otherwise optimistic. But the ones in operation tend to be slightly worse, G, F, but some of them are now beginning to be more Bs. And we thought, well, what's wrong with us? What are we doing wrong? And it seems that it's not us, actually. We set up the platform, the Carbon Bus database, to collect data and allow us to benchmark against our peers, as Anna said, anonymously. And we found that actually this, what we call performance gap, is really actually quite large. So on average, at least double in education sector, and similar for office buildings, where we are beginning to have quite a large number of data points. And we call it disruptive technologies because we're really going against the grain here in doing something like this, because professionals tend to tell you that this industry is already very well regulated. But all we are trying to do is understand what kilowatt hours are from the beginning to the end of the project. If you click on the evidence tab on the Carbon Bus website, you'll see that actually the design records are so much more optimistic than the operational ones. If you did a median education building in design and you delivered that with no performance gap, you would be one of the best projects in that spread. So the challenge is, how can we report this data in such a way that I can benchmark my project from planning to building regs, to the EPCs, to the financial incentives for renewable technologies and other energy-saving measures, to the display energy certification system, which is actually looking at measured energy use. It's a legal requirement in this country to produce this certificate for every publicly owned building. But it's not even like comparing apples and pears. It's like collecting apples and grapes and pineapples and all sorts of, it's my favorite slide. The reason for this is that compliance calculations, and many of you would have heard me talk about this a few times, compliance calculations do not take into account things like what your building fabric is actually going to be like when it's built, what your system specification will be like when it's built, will your fan inverters be enabled like you thought they would be? Probably not. And IT and appliance loads are just not taken into account. Things like special functions that people like to put into buildings, like Bill Bordas says, the Large Hadron Collider in the basement. You never calculate with real operating hours, so extended hours of operation, or even if your building just operates 10 hours a day, like, or 20, like some of the major asset holders in London have buildings like that. And the actual occupancy, not to mention building management. So how can we begin to think and target the full picture? And we've carried out now nearly 12, we're just starting our 13th building performance evaluation. And I think we're probably one of the few practices who can say exactly what these buildings are doing in use. I'm sure there would be other practices who have similar data, but I think what we pride ourselves on is actually putting it in the public domain. We think it is so important to share this data. It's such a big and scandalous problem that it needs to be, there needs to be a joined-up effort to tackle it. I don't know if you can tell which one of these buildings are the mechanically ventilated ones. Check the ones nearing red. What we found in some of these evaluations is that putting lots of kit in a building isn't absolutely necessarily bad, but it's a huge risk when it comes to energy consumption. And we're also very proud to show some of the more recently completed buildings where we're developing a more of a fabric-first approach, where we really consider how the building is going to be occupied, and do as few systems as possible, make the user controls very friendly. And lo and behold, we're turning out buildings that are now getting B ratings and such like. I'm going to share some of the more detailed lessons learned from an example of Oxford School in the east of London. What the Carbon Bus platform helps me as a sustainability coordinator for the practice do is I can track this project. So this is what the engineers predicted as part of their EPC, but a bit doctored early stages of the design. These were our first set of meter readings, and these are our second set of meter readings. Okay, you can get hold of this data. It's not totally impossible. Getting hold of this type of data, which tells you where energy is being used in the building, is not that easy. But if you see the red ones being heating, hot water, cooling, the yellow being lighting, and then appliance loads tagged on, actually everything was nearly 3 times higher in this building than when we started. Not only that, I love these diagrams. It's a metering strategy. How many of you have seen one of these before? Forest of hands. It strikes me that some of these diagrams relating to MEP systems are very similar to the grasshopper and some of the other parametric and relational diagrams that we actually work with. But anyway, metering strategy, have to familiarize yourself with it. Otherwise, you have to go and read these manually one by one which is not that much fun. The results coming out of it is really fun. Just going back on that one, you also have to do this for metering. Most of the time, missing meters, poorly calibrated, not hooked up to the building management system, so you probably have to do some of these manually anyway. If you're very, very, very lucky and special, then the meters do give you some results. And these are some AMR readings which show that the electricity consumption baseline is actually very, very high in this building. And although there is a weekend profile, even during the weekend, the energy consumption doesn't go away. And people just tell you this must be because of the IT systems. And it actually takes a little bit more effort to realize that it's not the IT systems. All of the buildings that we have monitored here have a reasonably high IT loads, but it's not them running overnight and fighting one another all day. It's actually the mechanical systems, supply of tempered fresh air. And even in this naturally ventilated building, we had a building management system, which you can think of as a rhino grasshopper model running in the background. Somehow, the seasonal commissioning was missed, and the temperature profile, so the triggers that tell the windows to open when it gets too hot, simply wasn't implemented. Very simple problem, incredibly expensive. We thought we were saving the client something in the range of £30,000 with a £2.50 solution. It did take me a few weeks of work to realize what the solution really was. But I was amazed that when we went to see the site, there was all these ground floor doors were wide open. Nobody told the facilities managers that you can actually retract the latch with the Allen key that we so carefully specified. Michael did, as you see him. And as a result, all these doors were open and all year round, and the £250,000 worth of ground source heat pump never kicked in because the heating temperature that you require is too high for that system to be efficient. So what a waste, eh? Lighting controls. Can you spot the problem? Any volunteers? I've also seen some light pipes having lights on all the time next to them. Yeah, beautifully lit building. I think perhaps what we forget as architects sometimes is that the reason why we're putting all these services into buildings is to keep us comfortable, happy, productive, sociable. And fair enough, we don't like to necessarily look at them, but even in this building, I mean, we're just listening to the fans going in the auditorium, and I don't know how cold you are, but I'm freezing. And what we tend to find is that when building management systems don't work properly, the building still can run and provide enough comfort. What we don't understand is how much extra energy it takes to do that. But this is an actually okay building because it's still naturally ventilated. Users still have a good control over its use. But when you look at a building where systems are really fighting one another and the energy consumption is really extreme, you'll see all of these suddenly coming out red. And that's a big lesson for us to learn. One of the things we never think about as architects, I don't know, maybe you do, but I didn't before, is how much does it cost to a project and the client to supply fresh tempered air to a space? It actually tends to be around 30% of capital cost for typical office buildings, and something in the range of 60 to 90% of the whole life cost of a building. That's quite a hefty sum. In fact, we were just looking at some data with one of the NGD students from the Energy Institute, Joe Jack Williams, seeing whether the current regulations, the current Part-L regulations, are incentivizing more complexity in new buildings. And as a result, although our fabric performance is getting much better and the heating requirements tend to be lower, the electrical consumption has actually grown, and we're looking into the data more carefully now to be able to validate that. Data can be useful, right? Holland Park School, an amazing project we have recently completed. I'm still trying to see whether the perimeter daylighting actually works in classrooms. We have managed to persuade the client to give us access to the building, and we are doing a broken down, like a fast and an extended post-occupancy evaluation on this building, and I really can't wait to see the results, because it is, no matter how much we talk about working with smart design teams and in a smart industry, it is incredibly difficult to persuade people to do things simply or just take very, very small risks, as Abdul-Majid has mentioned before. On this project, Keynsham Town Hall, we're piloting what I think is actually quite a revolutionary approach, in that we persuaded the client not to just go for the normal regs, but actually target operational energy use. So we're going for what we call a display energy certification rating of A. If you can pronounce that, you get an award. But it means that the building will consume very little energy, and we signed up to that contractually. What that means is that we're disclosing not just the energy model and the energy budget for the different end users, but also what the assumptions are behind these. And what's really amazing to me is that focusing on one little thing like that can completely turn the design process on its head. And this is the first project that I'm seeing where things related to the energy consumption of the building haven't been value engineered. So the lessons: do your targets properly, make sure they are well informed and relevant to the project, do your modeling properly, make sure you know what you need to take into account to make sure it works, and then go and look at how it works in operation, because you'll be surprised. And recognizing best practice, we've been quite successful at getting the professional bodies on board. Perhaps one other thing, just because we were talking about the cities and new cities and networked cities, how the configuration of cities will change. And this very much relates to the mechanical servicing of buildings as well. We tend to design very deep spaces because we can mechanically ventilate them. But actually, when you think of the adaptability of a building, you would want to design this floor plate shallower and taller so that you can convert them into different building types downstream. Not only that, but bear in mind, electric cars are coming, whether the batteries are sustainable or not. They are coming, and the noise and the pollution that cars give you are going to get lower and lower, and we can really begin to open up some of these buildings more especially that we're having a warmer climate. It's fantastic to see more energy disclosure led by North American cities. All of they're all beginning to put certification and information into the public domain. And yes, there are other drivers. This was a very quick study we did. In fact, my colleague Christian Derricks, who runs the computational design team at Aedas, developed this little Java app that shows the shortest distances between docking stations for the London cycle scheme. And what you see there is the mapping of the data, the actual data. And I think someone did something similar at UCL as well. I think this is basically showing the beating heart of London's cyclists. If you bear with it a little while, you can actually see the strike day. Lots of bikes are used. So I can't wait to get the feedback from this building.
Thank you, Judit.
Thank you.